Hello guys, welcome to my YouTube channel once again. In the last video, we talked about well logs, particularly gamma ray and resistivity logs. We also looked at an illustration showing how these well logs are acquired in a well. Okay? So in this video, we're going to look at these well logs curves, how they trend, and then interpret these curves based on good understanding of well logs patterns and their relevance in reservoir description. Okay? But first, we need to understand the specific objectives of well logs analysis. They include to locate where the reservoir is, to describe the reservoir, and then to identify the type or types of hydrocarbon contained in the reservoir. Alright? So with these objectives in mind, we know exactly what we are looking for. And this is key to achieving meaningful interpretation. Okay? So let's get started. If you have this type of well log curves, the first step in well log analysis is to carry out lithological interpretation. That is, to differentiate sand from shale. This will help us to locate the permeable zones. And the permeable zone logs are generally presented in track 1. Alright? So, on this track, we have gamma ray log with a baseline on the right hand side. And this is called shale baseline. This shale baseline indicates shale zone, which is impermeable zone. Okay? And then the log curves to the left hand side indicate sand zone, that is permeable zone. This is the center of attention because hydrocarbon are accumulated in reservoir sands. Alright? So after establishing the sand shale zones, the next step is to scan through the resistivity log curves, which is commonly presented on the second track. This will enable us to see which part of the sand gives high resistivity because the presence of hydrocarbon in reservoir sands reads high resistivity. Alright? So this high resistivity shows the presence of hydrocarbon from this sand top to this depth. And below the hydrocarbon, we have brine, that is, water with high concentration of salt, since we have low resistivity in this sand. But then, it is not clear what type of hydrocarbon is contained in this sand. Alright? So, we're going to use these porosity logs, that is, neutron and density logs, to determine the hydrocarbon types in the reservoir sands. Okay? So, the next step is to scan through the porosity logs, which is generally presented on the third track. If you overlay the neutron and density porosity logs in this manner, you will be able to recognize the fluid types, that is, gas, oil, and water, because neutron porosity log measures hydrogen concentration in a formation, while density porosity log measures the electron density of a formation. Okay? And since we have low neutron and density porosity logs, the type of hydrocarbon we have on top of this sand is gas. And then we have oil directly below the gas due to higher neutron and density porosity logs, because oil has high density and hydrogen index. And below the oil, we have brine, that is, water with high concentration of salt. And if you recollect that salt water has been identified by resistivity log in track 2. Okay? So, having established 3 fluid types, 2 fluid contacts can be identified. The first one is gas-oil contact, that is GOC. And the second contact is oil-water contact, that is OWC. Alright? We can also trace out the height above free water level. Okay? So with this well log analysis, we have been able to determine this sand top, gas zone, gas oil contact, oil zone, and then oil water contact. We have also been able to determine the salt water, that is brine, height above free water level, as well as the sand base. Okay, I actually used Pedro software to create these colorful fluid types and fluid contacts. What I did was to create a fluid template, and then I created a new discrete log by using the template that I created. Okay, so that is all I have for you in this video. If you have any questions or comments, you can get in touch with me through email, LinkedIn, or Twitter. And if you have any issues in any reservoir study or project, you can bring it on. Let us reason together and solve problems. Okay? And then don't forget to share and subscribe for more videos so that you can receive notifications as soon as I release new tips. Bye for now.